Hello everyone. We are Group 8. I am Kartikeya Sai and my teammates are Harsha Vardhan, Vishwanath, Nagadeep.
Let's dive into Polygon Zone-Based object and person detection. Firstly, let's get a gist of our project.
Hey, welcome to the Explainer. Today we're going to break down something that seems really simple on the surface, but is actually surprisingly complex. We're talking about the tech that lets a computer look at a video feed and count exactly how many things are inside a specific area. Sounds easy, right? Well, let's find out.
All right, so let's just dive right in. You see this image, right? A person's in a store aisle, there's a little zone drawn on the floor, and a big number 1 on the screen. To you and me, that is dead simple, obvious. But how do you teach a machine to make that same call? I mean, all it sees is a flat grid of pixels. How does it even know that's a person, let alone figure out if they're inside that zone in 3D space? That's the real challenge here.
So, here's how we're going to tackle this. First, we'll look at the core problem with counting. Then, we'll walk through the 4-layer solution they've come up with. We'll dive into how they teach the AI to see, and then how they add in geometry and memory. After that, we'll put it all together, and of course, peek into the future of this kind of spatial AI.
Since Kartikeya has explained what the whole project is about, let's see the technical problems we face and the outline of the solution we came up with.
All right, section 1, the problem with counting. So yeah, why is this so hard for machines when it's second nature for us? You have to remember, when a computer looks at a video feed, it's not seeing people and things. It's just seeing a massive, relentless stream of changing pixel colors on a grid. That's it.
And that leads to some major hurdles. I mean, first off, the computer just sees pixels, not actual objects. So how does it learn that this blob of pixels is a person? Then you've got real-world chaos to deal with, like occlusion. That's when people walk behind each other and get blocked from view. Plus, the bounding boxes the AI draws are just simple rectangles, right? They're not the exact shape of the person. And don't even get me started on perspective. A camera angle can totally throw things off. On top of all that, a video is just a series of still pictures. There's no built-in memory. Without it, the system would just count the same person over and over 30 times a second.
So, our next section, the 4-layer solution. So how do you actually solve this mess? Well, engineers didn't just build one giant, clunky program. No, they got smart. They created this really elegant, modular 4-layer pipeline that takes that messy video feed and turns it into clean, useful data. And what I love about this is how much it mimics how we think. It's really cool. So step 1 is ingestion. That's just grabbing the raw video frame by frame. Step 2 is inference. This is the eyes of the system. It's the AI model that actually sees and identifies objects. Then step 3, tracking. This is the memory. The system has to remember objects from one frame to the next so it doesn't get confused. And finally, step 4, spatial logic. These are the rules. This is where the system applies our geometry to figure out what's in the zone. So think about it. See, identify, remember, and then decide. It's a pretty logical flow.
Since Viswa gave the outline, let's understand the eyes of the project, a clear understanding of inference layer.
Let's get into it. Section 3, teaching the AI to see. We're going to start with the eyes of the whole operation, that inference layer. This is the AI model that has to learn to see objects in just a sea of pixels. And believe me, this is where the real magic starts to happen. So the engine behind all this is an incredible AI model called YOLO V8. And YOLO actually stands for You Only Look Once, which is like the key to the whole thing. See, older models used to have to scan an image over and over, sometimes thousands of times just to find stuff. But YOLO, it looks at the entire picture just one time to figure out what's there and where it is. It's a single-shot approach that makes it fast enough to work in real time on live video. It's a total game changer.
And this is why YOLO 8 is so darn good for this job. It's got a few killer upgrades. First, these things called C2F modules, which basically just help it see things better. Doesn't matter if they're huge and up close or tiny and way in the back. Then there's anchor-free detection, which is a fancy way of saying it draws much tighter, more accurate boxes around stuff. And finally, it has what's called a decoupled head. It basically separates the question of what is this thing from where is this thing, which makes it way more precise on both counts. All of this just means fewer mistakes and much cleaner data for the next part of the process.
Since Harsha has explained the inference layer, let's look into the mathematical and geometrical implications of the project.
All right, next up, adding geometry and memory. So our AI has its eyes. They can see stuff. Awesome. But now we have to add the logic so we can actually count things inside our zone. And this is where we move beyond just pure AI and get into some clever math and, you guessed it, giving the system a memory.
So how do you check if something's in a zone? Well, there's the slow way and the fast way. The slow way is basically to do a ton of math for every single object in every single frame. You check it against every single line of your zone. It's a lot. But then there's the fast way, a really clever shortcut called rasterization. Instead of doing all those calculations over and over, you just draw your zone onto a digital grid once, right at the beginning.
And here's why that's so brilliant. As this report says, checking if a point is in the zone becomes a simple array access. What does that mean? It means checking if an object is inside is as fast as looking up a cell in a spreadsheet. It's what's called a constant time operation. And that means it takes the exact same tiny fraction of a second, whether your zone is a simple box or some super complex, crazy shape you drew. That efficiency, that's what makes this whole thing possible in real time.
But hold on a second. How do you know if a box is inside a zone? I mean, what if it's only halfway in? This right here is the aha moment of the entire system. To get rid of any doubt, the system just collapses that entire 3D box down to one single point, an anchor point. And by default, it uses the bottom center of the box. So why there? Think about it. That's where a person's feet would be. It's where a car's tires touch the road. It perfectly maps the object to the floor. And just like that, it completely solves the whole camera perspective problem. So clever.
Okay, and to stop the system from counting the same person over and over, it needs a memory. This is where tracking comes in. So first, a tracker like ByteTrack gives every unique object it sees a persistent ID. It's kind of like giving it a name tag. Then, it uses something called a Kalman filter, which is just some fancy math to predict where that object is going to be in the very next frame based on how it's moving now. This makes the system smart enough to keep tracking someone even if they disappear behind a column for a second or get blurry. It all works together to make sure each person is only ever counted one time.
Let's conclude the presentation by putting it all together and by discussing about future steps.
Okay, section 5, putting it all together. We've talked about the theory, right? We've got the AOIs, we've got the geometric rules, and we've got the digital memory. Now, let's see how this entire 4-layer pipeline works in the real world. Let's take a look at this example from a grocery store. So, step 1 is raw detection. The YOLOVATE model just casts a super wide net and identifies basically everything it can recognize in the picture. And you can see all the different boxes and labels here. It sees the person, obviously, but look closer. It's also picking up individual bottles and other things on the shelves. It's just seeing everything.
Then comes step 2, filtering. This is really simple. Our goal is to count people, right? So we just tell the system, hey, ignore everything that isn't a person. And just like that, all those other detections, the bottles, the other stuff, they just vanish. The system doesn't care about them anymore.
And finally, step 3, the spatial logic. This is where all our rules come into play. The system takes that one-person detection, finds the bottom center anchor point, their feet, and checks if that single point is inside our zone. And look, you can see it right here. The second that little anchor point steps outside the line, the count instantly flips from 1 to 0. It's incredibly precise, it's super fast, and it just plain works. So what's next? Let's talk about the future of spatial AI. I mean, this technology is already super powerful. It's being used for everything from managing traffic to analyzing how people shop in stores. But believe it or not, engineers are already pushing way beyond these simple 2D zones.
And the stuff on the horizon is mind-blowing. We're talking about moving into the third dimension with 3D volumetric zones. So you're not just counting on a flat floor, but inside an entire 3D space. Imagine zones that can automatically resize themselves based on how long a line is getting. Or get this, multi-camera fusion, where a system can track one single person as they walk seamlessly through an entire building, past dozens of different cameras. We are really moving from just taking a snapshot of one spot to gaining a deep understanding of entire environments over time.
And all of this really leaves us with one big question, doesn't it? As these computers get better and better at seeing and quantifying our world with this incredible precision, what should we ask them to count next? Now that we have the tools to teach a machine to count almost anything, anywhere, what should we focus its attention on? What are the really important questions we can finally start to get answers to? Something to think about. Thanks so much for joining us for this explainer.
Thank you everyone for listening to our project.